for you. Okay, the geometry for this. Before we go into the geometry, let's calculate the co-length. Co-length means from the leading edge to trailing edge. The length here we call this the co-length. Okay, 我们称为它的 co-length here. Okay. So as you can see, our transformation here. This is our transformation. Our circle is so our z is equal to zeta plus c squared over zeta. This is our Jacobi transformation. And our zeta is at the trailing edge here. Our leading edge here, okay, is equal to what? Leading edge here is zeta is equal to minus c plus 2m. Okay, you can check. So this point is zeta equal to minus c plus 2m. Okay, so we kind of try to apply this point to see how this point through the Jacobi transformation, where is it located. Okay, so we plug this point into this Jacobi transformation. So zeta equal to this value. Okay, this is this point, and zeta here we apply. And then if you rearrange, okay, our formula become 1 plus 2 epsilon and minus. And since epsilon is very small number, right? This epsilon is very small number. We can apply the so-called the theory of the formula like this. If you have a 1 plus, okay, 1 plus a very small number to the a squared, a power will be approached to the 1 plus a. If you know much okay, 可以用这个公式 okay, 1 plus a very small number with the power a here will be approached to be very close to the 1 plus a times this number. Okay. So once we apply here, as you can see, this is a 1 plus 2 epsilon to the minus 1, right? So 1 plus 2 epsilon to the minus 1 power will be equal to 1 minus 2 epsilon. Okay, that's it. Okay, so from here to here we apply this theory. Okay, this kind of approach. Okay, and the C, this is minus C, this is minus C, give you the minus 2C, and this is epsilon. This is epsilon. Epsilon is a very small number. Okay, so this will be very small number. So when the epsilon is very small, the length here, okay, the length here, or here, okay, at this location here will be give you the minus 2c. So here is a minus 2c. The location for the leading edge is minus 2c. And the trailing edge here, as you remember, our critical point will be through Jacobi transformation. The trailing edge here is equal to 2c. So length here is equal to what? It's equal to 4c here. Okay, that's a co-length. Okay, or very close to the 4c. Okay, to the first order in epsilon. 所以我们的记忆的长度的旋长 ，OK，the co-length 大概 L 大概等于4c， OK，L is equal to 4c for the Jacobi L4 here. Okay, the second thing is the equation for Jacobi L4 surface. OK， 它的方程式怎么就这是这个整个方程式。The equation for to describe the L4 shape or geometry, we can also calculate. Okay, so how do we calculate the equation for the Jacobi L4 surface? Okay, again we apply so-called through this Jacobi transformation. So this is circle, right, in the zeta plane. Through the Jacobi transformation, we will find this surface here. And before we go into the, okay, we first see the zeta plane here. This is A here, right? A is equal to what? Okay, A is equal to, if this is a coordinate system, right? And coordinate system usually you're using this is R, this is mu, right? 所以这个地方我们用的是极坐标 polar coordinate, 对。So if you have this, okay. We have a circle with a center here, right? This is center here. We have a circle here. Okay, and this point is C here. And this is we give a coordinate by using this coordinate. Using a polar coordinate here. Any point here can be described as this is distance from here, this r, and times mu, right? So that for this point P here, P can be described by r, e, I, mu, right? The polar coordinate. Okay? And here, since the center is here, so we know from here to here is what? It's A, right? Because our radius is A. Okay? And then we apply this triangular, 我们用这个三角函数，三角函数这个地方用 we apply this okay, this triangle here. So here is the length is A, and here is what? Here is R, right? So this is R. Okay? And what's this here? M, right? We have M. So we have the M. Right? M. So we apply this triangle here. So this is A, this is R, this is M. And we also have angle. Angle here. This is angle is what? Mu here, right? This is mu. So I apply so-called cosine theory. What's the cosine theory? 什么是余弦定理？大家记得什么是余弦定理 ？If I have the ABC and I know it's A equals theta, A squared what is equal to B squared plus C squared minus 2BC cosine theta, right? That's a cosine theory. 余弦定理，三角函数里面的余弦定理。所以 A 这个边长的话，跟 BC 的关系是这样。同样的 ，this A length here, we have to know the angle here, right? Angle here. The angle here is what? The pi minus mu, right? So I apply this cosine theory, okay? We have this A squared. Okay? A squared equal R squared plus M squared minus 2Rm cosine this angle. Angle is pi minus mu. Okay, so this is a cosine theory, and cosine pi minus mu equal to cosine mu. Okay, you can check. Okay, that's a cosine. Okay, you can, and by using this we kind of rearrange this equation. We take out the r, common factor r squared out of this bracket. So this become 1 plus m squared over r squared divided by 2m over r cosine mu, right? So this is a squared equal to this. Okay, and we copy this a squared equal to this here. Okay, 我们把它抄过来。Okay, and what we did is what? We did this is 1 plus 2m over r cosine mu here. Okay, and we plus 1 of the m squared over mu over r squared cosine square mu, and then we plus 1 of this and minus 1 of this. 我们加一个减一个是一样。Okay, as you can see here, for this three term here is equal to this three term here, which plus this term and minus this term should be exact the same. We didn't did anything, and in order to why do we want to add this term? Because we like to let this term become what? 1 plus 2m over r cosine mu plus m squared over r squared over cosine square mu equal to what? Equal to this. 1 plus m over r cosine mu squared. 所以这三项 the first three term can be concluded like this. Okay. 对，前面三项就是 a 平方加 b 平方加 2ab， 就是 a 平方加 2ab 加 b 平方。Okay. Okay, will be equal to this. Okay. And the last two terms here can be summarized here, right? But we can common factor is m squared over r squared and become 1 minus cosine square mu here. Okay, and what we can do even more is okay, as you can see, m over r is what? M is a very small number. M over r, m square even smaller. So this term here is the order of the epsilon square. So epsilon is a very small number. Epsilon square even smaller. We can neglect this. So only the leading term will be survive here. Okay, 我们就只取 okay 比较主要的项 okay So the leading term a squared will be equal to this. This is a very small number, so we can drop. Okay. So we can kind of describe A like this. Okay, this is all mathematics. I just try to give you the, okay. And again, we can also apply A is equal to C plus, okay, M, right? Because A is equal to C plus M. Okay, from here to here is A, right? And this is M plus C. And M plus C can be equal to C times 1 plus epsilon, because epsilon is equal to M over C. Okay, so as you can see here, okay, and then this A will be equal to this, right? This is equal to this, and then A squared is equal to this. So A is equal to what? Is equal to R times 1 plus M over R cosine mu. So this is A again. So we can have this relationship, okay. And this relationship here, if you multiply R inside this bracket, this is become R times plus M cosine mu. 你把 R 乘进去的话，就变成这一项。Okay. Now M is equal to C epsilon. Okay. And by apply these two, okay, the equation by equal this and this, okay, we can find out our R. Okay. 我们可以找到这个 R. Okay. R is equal to what? R is equal to this minus this, right? So this minus this equal to our R. Okay, 所以我们可以找到我们的 R. Okay. Once we know the R, okay, the rest is easy. Okay, this is R here. Okay, 这个 R 是从这个地方抄过来的。Okay, R 是这个。R is the coordinate, right? R 是一个所谓的我们的坐标的系统，极坐标的系统，就是 polar coordinate 的一个 R 的一个变数。所以 our laser can be represented as R E I mu, right? Any point, okay? 所有的点都可以变成 R E I mu. So here for this R is on the circle here, okay? 所以这个地方我们的 R 是在 circle 上面。Okay, so we apply this R by using this to describe all the point or the coordinate on this circle here can be represented by this. 所以我们把这个 R 在 circle 上面的 R 是等于这个，然后所以在 circle 上面 on the circle surface here, our coordinate on the surface, okay, can be represented as zeta equal to R E I mu. Okay. Through the Jacobi transformation, we transport this surface to the z-plane. Okay, so what we did is just apply this. So our R is equal to this, okay, times EI mu. So this is R EI mu can be applied to here, give you the zeta. And this is C squared here over zeta. Zeta is R EI mu. So by doing that, we can represent the after the transformation in the z-plane coordinate. 所以我们可以最后把这个 z plane 上面的所谓坐标轴做出来 ，okay, and go through a little bit mathematics, but not very complicated. Just z is equal to what? Real part is x, imaginary part is y. So we just kind of transform this into the real part and imaginary part, and later you will find our x is equal to this, y is equal to this, and y have the positive negative here. 所以 y 有两个值，一个是正值，一个负值。If you plot this, you can find out this is our geometry. Okay, for any location of x, we have one is positive, one is negative, corresponding to our airfoil on the upper surface and the lower surface. Okay, 所以我们最后可以得到这个整个的公式，就代表这个 airfoil 的形状。Okay. 所以这个是我们的最后的结果。This is our final result for x and y is represent the geometry or the coordinate system for our airfoil shape. Okay, for x and y here. And we also interested in what? We also interested in the thickness of the measurement thickness of airfoil. 我们有感兴趣到底这个机翼到底多厚 ？Okay. So measurement thickness is here. This is the thickness here. Measurement thickness is here. Okay. So how do you find this measurement thickness location? Since we already have a y, okay, and so this is y. By applying this into we can find out our y is function of x. right? Function of x here. 因为这是 cosine mu， 对，这边有 cosine mu， OK， we can change our cosine mu to the x, and once we change, it will become like this, and sine mu will become the change to the sine square plus cosine square equal to 1. So we can also replace the sine mu to x, become like here. OK， 所以这个地方我们全部把它换成 x. We change all the parameter or all the variable to x. So y is a function of x. To give you the coordinate system for the surface of L4 here. So we using the y equal to this, and here this is our coordinate system for L4 here. And we try to find a local minima, local maxima for the thickness y. Okay, y minima, y maxima. And in order to find the y local minima, local maxima, the y we can take a dy dx equal to 0. Okay, or dy d mu equal to 0 is the same. Okay, so here is mu is a variable. This is x is a variable. Okay, so dy d mu, if you're using this is our mu is our variable. So dy d mu equal to 0 give you the local minima, local maxima. Okay, 所以你就在微积分里面 in the calculus, in order to find the local minima, local maxima, we try to find the dy d. Okay, for this formula dy d mu here equal to 0 for this point. Okay, the location can have a dy d mu equal to 0, give you the local minima, local maxima. 所以你把它做微分一次 we take a derivative here, will be give you this. 你把它微分一次 and find equal to 0 and try to find the mu. And once you can find the mu is equal to 0, okay, and 2 pi over 3 and 4 pi over 3, these 3 points, okay, will give you the dy d mu equal to 0. Okay, and then when mu equal to 0, that's to give you the trailing edge here. Trailing edge because that will be a local minima thickness. Okay, and for here and here we can find out this is our local maxima location. So for mu is here and mu is here, give you y is a positive value, y is negative value, and this is give you the location for this, and the thickness is equal to the from here to here equal to our thickness. Okay, 所以这个就变成是我们的厚度，这记忆的厚度。所以 the thickness will be equal to 3 times square root of 3. Okay, and epsilon c here. Okay. 进来一点才看得到 ，missing 掉一些。Okay, move. This is move inside a little bit. Okay, so that will give you the T measurements here. Okay, so this is the L4 thickness. The measurement thickness is equal to this. So as you can see here, epsilon times C give you M, right? Because if you remember what's the epsilon definition, epsilon definition is what? Epsilon definition is M over C, right? M. So if C times epsilon give you M, M is what? M is this distance here. Okay. Now will be corresponding the thickness, right? As you can see, now thickness here. Okay. Our thickness here. The L4 thickness here will be equal to 3 times square root of 3 times epsilon c. Epsilon c is equal to m, 对不对？所以 m 就代表什么？你可以去调那个 m， 去调它的厚度。Okay. So once you check, you can adjust this m here, epsilon c here, to give you the t measurement. Okay. So this is the relationship, okay, with epsilon, okay, and so if you change it, because the t measurement here, okay, the epsilon and c is what? C is equal to L is a co-length here. Co-length is equal to 4c. So this is if you're using the L here, you should multiply 4 here, and the value here give you what? Give you the 0.77. 0.77 T measurement divided by L. And that's very interesting, okay? Because always we would like to represent the measurement thickness normalized by our co-length. So this is our measurement thickness. 这是记忆最厚的地方。这个记忆最厚的地方，我们又常常就把它怎么样无因次化？什么无因次化？我们跟它的 co-length 跟记忆的旋长去做无因次化。So this is T measurement normalized by L. Give you the ratio of this and over this, and give you the thickness, okay, parameter. So this T measurement over L will be equal to this. It's much less than 1. So that will be. So once you did that, our L4 shape can be replaced by become the T measurement or an L. So this is once you apply this is our original equation for the L4. Okay, and by apply this and this, we can give you this. Okay, so that will be give you the complete L4 based on the T measurement and the co-length. So this is the co-length, this is T measurement. If you want to generate the co-length L and T measurement for here, you can using this formula, and by adjust your Jacobi coefficients, to give you the exact formula or exact L4 you want. Okay, so I think I will stop here for a while. Okay, that will be the go over the L4 with the thickness. 我们休息一个10分钟。Okay.